Hello everyone. So we're going to start with question number 23, in which we have let s equals to t which belongs to R. So fx equals to mod x minus pi into e to the power mod x minus 1 sine mod x, which is not differentiable at t. Then we have to find the set s, the value of set s. So we will first simplify the equation. Fx equals to mod x minus pi bracket x to the power mod x minus 1 into sine mod x. Obviously it is differentiable at 0, so we will check x at pi. So we'll put the value of x at pi, which is the normal simple formula, pi plus h minus f pi upon h. Limit h goes to 0. After putting the values, we have mod pi plus h minus pi mod e to the power mod pi plus h minus 1 into sine mod pi plus h minus 0 upon h. Now we will open the mod in the next step, and limit will be h goes to 0 in all. So after opening the mod, we have h into e to the power pi plus h minus 1 into sine pi plus h upon h. On further simplification, we will have sin h minus sin h into e to the power pi minus pi plus h minus 1, which is equal to 0. This is our right hand derivative. Now we will solve left hand derivative, which is f pi minus h minus the f pi upon minus h, which is another formula. So after putting the values on this formula, we have limit h goes to 0 mod pi minus h minus pi e to the power mod pi minus h minus 1 into sine mod pi minus h upon minus h. On the last simplification, we will have limit h goes to 0 h into e to the power pi minus h minus 1 into sine h upon minus h, which is equal to 0. So here we open the mod, and it is differentiable at pi equal to x equals to pi. Therefore our answer will be pi. This is a hidden dot method, but it's very obvious while we practice for it further. So we'll go with answer number A. Thank you.